Hello, once again, welcome. Like you can see on the board, we just finished considering subtraction in binary number system. We have also done addition in binary number system. So now we're proceeding over to do multiplication in binary number system. Multiplication in binary number system. Multiplication, multiplication in binary number system. In multiplication in binary number system. Multiplication in binary number system. Kindly pay attention. I will take example 1. Example 1. And example 1 is saying evaluate the following expression. Evaluate or solve. Evaluate the following expression. Evaluate the following expression. So, an example 1 is saying multiply 101 by 11. Multiply 101 by 11. It's still as simple as ABC. So what do? We simply write solution. But mind you, it's not the same thing like normal multiplication, like as in base 10 multiplication. It's not the same thing. It's entirely different. That's the more reason you need to pay attention. So what happens? We write 101 times 11. But first, we need to start as in normal multiplication before we proceed over to do the right thing, as in converting to base 2. So now we'll carry out original multiplication like in base 10, where we'll say 1 times 1 is 1. I actually need space to do this. Okay, let's go. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. So 1 times 1 again, 1. 1 times 0, 0. 1 times 1 gives you 1. Now, all we had just done is the usual multiplication in mathematics, as in base 10. The multiplication you come across every day while multiplying base 10. Exactly what we have just done. So now is the time to convert to base 2 by applying this principle. 1, remember, you're dealing with base 2. So now, here is 1. 1 plus 0, this empty space is 0. So 1 plus 0 is 1. And 1 divided by the base, which is 2, gives you 0. It can't go, so we write 0, remainder 1. Write down 1 here. Or the one you cram, whereby you say 1 plus 0, don't forget this, plus 0, it is a standard measure, which is 1 plus 0 is equals to 1. What we got here. That you are applying the principle of cramming, or you're applying the basic principle, you to get 1. So, the next, 0 plus 1 gives you 1. 2. Divide by the base also gives you 0, remainder 1. The same thing here. So, anytime you have 1 plus 0 or 0 plus 1, as in 0 plus 1 is still 1. So, we write the 1 down. Or you apply this principle. So, 0 plus 1 is 1. Apply this or apply this. So now the next one is also 1 plus 0. The same thing as 1 divided by the base gives you 0, remainder 1. Write down the 1 here. Nothing is here. It means here is 0. So 0 plus 1 gives you 1 again. So 1 divided by 2 again gives you 0, remainder 1. Write down the 1. Whenever 0 comes first, learn to forget it. Needless, writing the 1 at the end. It then implies that if you multiply 101 by 11 or by 1, you're going to get 111, then 1. So for better understanding and for more explanation, we take another example. We take example 2. Let's take example 2. And example 2 is saying we should multiply example 2 is saying we should multiply the values, which is multiply 1, 1, 1, which is 111, 0 by 101 by 101. Actually need space to do this. So now what happens? Solution. We're going to write 1, 1, 1, 0 multiplying by 1, 0, 1. We are multiplying. Step number 1. Multiply like you have in base 10. Multiply like you have in base 10. Thereafter, we take step 2, which has to involve converting to base 2. So let's go. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 again is 1. 1 times 1 is 1. The next, 0 times 0 gives you 0 times 0 gives you 0 here. 0 times 0, no, 0 times 1 gives you 0. 0 times 1 gives you 0. 0 times 1 gives you 0. The last line. 1 times 0 gives you 0. 1 times 1 gives you 1. 1 times 1 gives you 1. 1 times 1 gives you 1. Now, here is where you needed to convert to base 2. You don't add it like you have in binary and leave it like that, as in decimal. You don't add it as like you have in decimal and leave it like that. You have to do a conversion to number base, to binary number base. So now 0. Interesting enough, even if you say 0 divided by the base, which is 2, it still give you 0 remainder 0. So you write down the 0. Like saying 0 plus 0 is still 0. So 1 plus 0 is still going to be the same thing, 1. Even if you apply these techniques of saying 1 plus 0 is 1 divided by the base, this will be more helpful to you while dealing with higher number bases. It will be more relevant and important to you while dealing with higher number bases like base 3, base 4, base 5, base 6, base 7, and all that. So now what happens? The next line, 1 plus 0 plus 0, still going to give you 1. Let me complete this. It's 0 remaining 1. That was how we got the 1 here. 0 plus 0, 0. 1 plus 0, it is 1. Divided by the base, which is 0 remaining 1. Bring out the 1 here. Next line, 1 plus 0 gives you 1. Divided by 2 again gives you 0 remaining 1. So write down the 1 here. The next line, 1 plus 0 plus 1 is 2. You say 2 divided by the 2. 1 plus 1 is 2. Divide by the base. The 2 you got, which is 1 plus 1, gives you 2. Divide by the base, because you're working in base 2, which gives you 1, remainder 0. You write down the 0. You write down the 0. Or from the cramming system where you have 1 plus 1 gives you 10. So the same thing, 10. Write down the 0 first, carry the 1 over to the next line. Bring the 1 here. So when you add 1 plus 0 plus 1 gives you 2 divided by 2 again. Gives you 1, remainder 0. Or 1 plus 1 gives you 10. So now write the 0, carry the 1 over. The same thing is applicable. The same thing is going to be applicable here. The same is going to be applicable. So what happens? Here is going to be 1 plus 1. 1 plus 1. If I say 1 plus 1 gives me 2. So, which is 1 plus 1 is equal to 10. I'm going to write 10 here. Or simply 2 divided by 2 again gives you 1 remainder 0. Write down the 0, carry the 1 over. No other number. Bring down the 1. That is it. As simple as ABC. So thank you very much for being part of this class. Hopefully I'm going to see you in next class. We're going to be considering addition and subtraction in octenary number system, which is base 8. See you over there. Thank you.